I'm given an array and it's sorted, but it's rotated. For example, here's a regular sorted array, 0, 1, 2, 3, 4, 5, 6, 7. It might look like 4, 5, 6, 7, 0, 1, 2. And that's just a rotated array that's been rotated how many times? 0, 1, 2, 3, 5 times. So at index, I assume 5, it'll be 0, 1, 2, 3, 4. Or at index 4, that's where I'm going to find the minimum number. And that's the output. I need to find the index of the minimum number. So I need to find the location of where 0 is. But it doesn't have to be 0. It could be any regular sorted array, and I just need to find the smallest number. So I understand that I'm given an array, just a regular integer array. So input integer array, and it's sorted, also rotated to complicate things. And my output is the it's an integer. An integer represents the index of the smallest number, smallest value in the array. And as for match, it's going to be a search for a range problem. And at the end of that problem, we kind of learned binary search. And we're going to apply this the same method to solve this problem. It's going to be slightly altered from that problem, but yeah, this is going to be a very similar approach of starting from the middle and then bias it to the left or bias it to the right to find the answer that we need. So yeah, we're going to use the binary search. So what's the plan? So I know the plan of a binary search is first I need to look for the low. I also need to look for the high. So the low will be the lowest index. So it's always going to be 0 when I'm working with arrays. And high is always only going to be the last index. Not the number of elements, but the last index. So, and I also need to find the midpoint. And the midpoint is always, well, that'll be in a loop. So let's start the loop. So while low is less than or equal to high, now we're going to find the midpoint. The midpoint is always low plus high, and all divided by 2. And I'm going to use integer division since I'm working with indices. Decimals do not help in this at all. So middle point, low plus high divided by 2. Now, what if, let's see, input array. Let's call this input array. If input array at mid, and then the condition, the pattern is like if there's a number smaller than the previous number, then I found my match. This number is the smallest number because it was previously sorted and it's just rotated. If there's a number smaller after the previous number, immediately that's what we want. So input array has to be less than the previous one. So it's going to be mid minus 1. And luckily with Python, we can work with the negative indices. If it was C++, I would have to do a more fancy if condition just to avoid negative indices. So, but for now, we don't need to worry that. We're working on Python. So, if we found it already, then, well, then I just need to return mid. Found my answer. Now we need to drive this problem. We're not gonna, what if we don't find the answer here? So now we need to actually drive. So we're gonna look at input array at the mid, and we're gonna see if it's greater than high. Input array at high. If that's true, that means the left half is normally sorted, everything's fine. So that means the answer lies in the right side. So that means I need to move the low all the way to a half point. So when we look at mid, plus 1. And else. And if it's the other case around, if the input array is less than the input array at high, that means the right side is sorted. So the answer lies in the left half. So I'm going to move down the high to mid minus 1. And let's see. And I like to return something here, just no. Python, I could return none. I like to return a low. It's well, not a, but the input array. Input array at low. This shouldn't matter much. Now, I need to worry about when there's only two, or I need to worry about when the array is already sorted from left to right, no rotation. So there's a check here. I need to check at the bottom. So input array at low, if it's less than or equal to input array high, then I just need to return input array. Oh, sorry, not return input array, return low, and that's it. Because if it's already sorted with 0 rotation, then the smallest number is all the way to the left already, and that's all they need to do. And even if there's let's see, even if there's only 2 elements, this will still work thanks to the negative index. So we don't need to worry too much thanks to Python, and that's really all there is to do it. If the answer lies in the right half, then yeah, we're gonna move the bias search to the right. If the array at mid is less than the high, well, that means the right side is sorted, so the answer lies in the left half. So we're gonna bias our search to the left side. So we're gonna cut down the high down to mid minus 1, and this should give us the time complexity of O of log of n. And that's all there is to it.